Okay, so in chapter 8, we will be talking about polar coordinates. First thing I'm going to talk about is the difference between rectangular coordinates versus polar coordinates. So certain curves are more naturally described in one coordinate rather than another. Keep in mind, rectangular coordinates are x, y. When we deal with polar coordinates, we'll be talking about r and theta. And so, if you remember rectangular coordinates were x, comma, y, and polar coordinates are r, comma, theta. We'll talk about what r and theta are. R represents a distance, theta represents an angle, either in degrees or radians. Using rectangular coordinates to describe lines, parabolas, cubic curves, circles, things that you guys have done before in Algebra 1, Algebra 2, and even pre-calc, FST. But we can use polar coordinates to describe lines, parabolas, circles as well. But the more common use for polar is to describe those graphs that don't work well in polar coordinate systems, such as cardioids, limicones, and lemniscates. Here are examples of what those graphs look like. We'll look at these graphs tomorrow in 6 or 8.2. Here's what a cardioid is. A limacone has a loop within itself. We have roses. We're not actually going to learn about roses, but that's what they are. Then you have a lemniscate. Kind of looks like a biscuit. That's how I remember lemniscate. Kind of looks like a biscuit. A polar coordinate. Okay, so a polar coordinate describes the location of a point in terms of direction and distance. All right, the location of a point is given by an ordered pair, r comma theta. We already said that r comma theta is a polar coordinate, where r is the distance from the origin or the pole. All right, so r is the distance from the origin. Here's our origin. Here's our origin here. And then it's the distance from there, which represents r. Theta is the angle from the positive x-axis. As we've known already from chapter 5 and chapter 6, here's theta represents this angle. All right, it represents the angle from the positive x-axis. That is our theta. Okay, so let's talk about the polar axis. The polar axis. Polar coordinates are where P, the point P, r comma theta, where r is the radius, the distance from P to the pole origin. Absolute value of r represents a distance. R can be positive or negative. Now let's talk about r being positive or negative. If r is negative, then P is on the opposite ray from the terminal ray of theta. That'll make more sense when we do the examples. But I'll try to show you now. But if r is negative and we had an angle, let's say we had an angle, the one in the diagram here, it looks like it's probably about pi over 3. So if I went pi over 3, and I said that r was a negative distance, let's say it was a negative 2, instead of it being here, I'd actually put it opposite there to be here. All right. Negative just means in the opposite ray. And I'll show you that when we do examples. And then when r is positive, it's just normal. And then theta is normal as well, as you learned in chapters 5 or chapter 6. Theta is the angle. Theta can be in degrees or it can be in radians, and it's rotational. It can be positive or negative. So keep in mind it's rotational, and that's why this graph is called a polar graph. Polar axis is different than a rectangular axis where you just have your x and y axis. Okay, so plotting points in polar coordinates. The first one, if you look at this one, it says the r is 1 and theta is 3 pi over 4. I'm looking at this example here. Well, if that's the case, that means that theta is 3 pi over 4. So I opened up a rotation from the positive x-axis, 3 pi over 4 in radians, and I went out a distance of 1. Keep in mind, if the 1 was negative, I'd actually go this direction. I'd actually go the opposite direction if it was negative. But it is positive, so it is where it is. And that point ends up right where it says there. The next example over here, this example is 3 comma negative pi over 6. As you know, if the angle is negative pi over 6, we go clockwise, negative pi over 6. So I went clockwise, negative pi over 6. And then I want a radius of 3. And you can see the tick marks representing units of measure. So 1, 2, and 3. All right, and our point P ends up right there. This example down here, example C, it says it's 3 comma 3 pi. So remember what 3 pi is, and keep in mind what I actually look at is the theta first, and then I take care of the radius. So 3 pi is once around is 2 pi, and then one more pi around is 3 pi. And then I go out a distance of 1, 2, 3. If it were -3, I go the opposite direction. I'd go 1, 2, 3 that way. Okay, just keep that in mind. D, you'll see here's the example where it's negative. So -4 comma pi over 4. So first I open up theta, pi over 4. And then instead of going out 4 units like normal, I go the negative ray from pi over 4. I go the negative distance, 1, 2, 3, 4, and then that point ends up. Okay, so let's go ahead and plot some points. It says the direction theta, then the distance r. So again, I look at theta first, and then I figure out the distance r. So if it's 7 pi over 6, you can already notice, I already marked the point. Let's see how we get to that point. 7 pi over 6, we already know how to do 7 pi over 6 from chapters 5 and 6. So 7 pi over 6, if we count it, 1, 2, 3, 4, 5, 6 pi over 6. 7 pi over 6 is here. All right, so this line here is 7 pi over 6. And I go out a distance or radius of 2, 1, 2, and that's how I get that point to be 2 comma 7 pi over 6. Never hurts to go ahead and label the point. 2 comma 7 pi over 6 is that point. Okay, next example. 4 comma negative pi over 3. Again, the point is already marked. Let's see how we get there. Negative pi over 3. Negative pi over 3, remember to go clockwise. So 1 pi over 6, 2 pi over 6 gets us here. That angle gets us there. Negative 2 pi over 6 simplifies to negative pi over 3. And then I go out a radius of 4. 1, 2, 3, 4. And that's how we get to that point. Let's look at another example. A couple more examples. Negative 3 comma pi over 4. All right, point's already marked, but let's see how we get there. Pi over 4, our angle pi over 4 is pi over 4 is here. So normally I'd be here. Then I count out 3 if it was positive. But since it's negative, I use the opposite ray and go the radius of 3. 1, 2, 3, and that's how we end up at that point. So if you take a look at this one, it says -4 comma -3 pi over 2. What are some other polar coordinates that would represent the same point? So before you go on to the next page, I want to have you pause and see if you can write down maybe 1 or 2 other ways you can get to this exact same point. All right, so the one that I gave you was -3 pi over 2. So -3 pi over 2 does go like this. So if you knew how to get there, -3 pi over 2 is here. But I go the opposite because the radius is negative. Opposite ray is 1, 2, 3, 4. Well, is there another way to get to this point? Think about going this way and then going positive radius. So see if you can write down 1 or 2 other ways to get to this point. Hit pause now, and hit unpause, and I'll give you like 3 or 4 other examples. Okay, so here's just 3 different examples of different ways to get to that same point. See if you maybe had one, maybe had a different one. Maybe it works. 4 comma negative pi over 2, -4 pi over comma pi over 2, and 4 comma 3 pi over 2. So just make sure all those work for you. Our last example, it's a little bit tricky, but it's 2 comma 2. That theta is in radians. I want to make sure I was clear about that. Theta equals 2 radians. All right, think about what 2 radians is. Now, there's a way to convert radians to degrees. In this case, the way to convert to degrees, we actually didn't teach you guys this over distance learning, but you take your radians and multiply by 180 over pi. That angle degree would come out to be about 114.6 degrees. But instead, you also know that radians, this is 0, halfway around is pi, which is 3.14. Half of that is 1.57. So somewhere in here is 2. All right, so I put it about there, and then from there, I went out a radius of 2, so 1, 2, and that's how I marked that point. So this point is 2 comma 2, a radius of 2, and theta also being 2, all right, in radians. Okay, so that's your first video. on 8.1. Make sure you watch the other two videos on 8.1.